Good day, everyone. I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about factoring perfect square trinomials. Perfect square trinomials is the result of squaring a binomial. A perfect square trinomial has first and last terms, which are perfect squares, and the middle term is twice the product of the first and last terms. That is, a plus b squared is equals to a squared plus 2ab plus b squared, or a minus b raised to 2 equals to a squared minus 2ab plus b squared. So these are the steps in factoring the perfect square trinomials. Step number 1, examine whether the first term and the last terms are perfect square. Step number 2, look at the middle term, check whether it is the twice as the product of the square root of the first term and the last term. Step number 3, if the conditions 1 and 2 are satisfied, then the expression is a perfect square trinomial. Step 4, factor completely the given trinomial following the pattern a squared plus 2ab plus b squared is equals to a plus b squared, or a plus b times a plus b. Similarly, if we have a squared minus 2ab plus b squared, that is equal to a minus b raised to 2, or a minus b times a minus b. Let's have example number 1. Factor n squared plus 16n plus 64. Now remember the step number 1, we need to determine whether the first term and the last term are perfect square. So we have here for n squared, the first term, that is n. So when we square root n squared, that is n. So if we will change that one into exponential form with the power of 2, that is n raised to 2. For 64, the square root of 64 is 8. That is 64 is a perfect square. That is 8. So 8 times 8. So we have here 8 raised to 2 when we change that one into exponential form with the power of 2. Both are perfect squares. So step number 2, determine whether the middle term is twice the product of the square root of the first term and the last term. Our first term here now is n and the last term is 8. So twice the product of n times 8, we must have the result of the middle term, that is 16n. So 16n is equals to 2 times n times 8. So 2 times n, 2n times 8, that is 16n. That is correct. Since the conditions are satisfied, then n squared plus 16n plus 64 is a perfect square trinomial. Then we can now factor it completely by following the factored form, that is n plus 8 raised to 2, or n plus 8 times n plus 8. So to factor perfect square trinomial, use the following relationship. The a squared is the first term raised to 2, and the middle term is 2 times the first term and the last term. The last term, we will need to raise to 2 that one, equals to a plus b raised to 2, that is the first term plus last term raised to 2. And for the difference also, we have a squared, the first term squared, minus 2 times the first term and the last term, plus last term squared, that is equal to first term minus last term raised to 2. Example number 2, we have factor 4x squared plus 4x plus 1. So determine whether the first term and the last terms are perfect square. So we have 4x squared. So the square root of 4x squared, we have 2x. That means 4x squared is a perfect square. So we can change this one to exponential form with the power of 2. So we have 2x times 2x, we have 2x raised to 2. And the last term, we have 1. So square root of 1 is 1. So 1 raised to 2, we can change this one into exponential form. Both are perfect square. Determine whether the middle term is twice. What is our middle term? 4x is twice as the product of the square of the first term and the last term. Our first term here is 2x and our last term is 1. So twice, so we have 4x is equals to 2 times 2x, that is 4x times 1, that is 4x. Since the condition 1 and 2 are satisfied, then 4x squared plus 4x plus 1 is a perfect square trinomial. So now we can factor completely 4x squared plus 4x plus 1 as 2x is our first term plus 1 our last term raised to 2, or 2x plus 1 times 2x plus 1. Example number 3, we have factor x raised to 2 or x squared plus 14xy plus 49y squared. So let's determine the first term, which is x squared, and the last term, which is 49y raised to 2, is a perfect square. So we have the first term square root, so that we can easily find if it's a perfect square or not. So you just need to square root, no? Or you can factor that one, x times x, by the similar base. So we have square root of x squared, we have x, so we can change this one into exponential form. We have x raised to 2. And the last term, square root of 49, that is 7, square root of y squared, that is 7. So we have 7y raised to 2 when we change that one into exponential form with the power of 2. Then they are both perfect square. So determine whether the middle term is 14xy, is twice the product as the square root of the first term and the last term. So we have 14xy is equals to 2 times x times 7y. So since the condition are satisfied, condition 1 and 2 are satisfied, then the x squared plus 14xy plus 49y squared is a perfect square trinomial. Now, we can factor it completely by following a plus b raised to 2, where our first term is x and our last term is 7y. So we have here x plus 7y raised to 2, or x plus 7y times x plus 7y. Example number 4. Factor 3x squared minus 18xy plus 27y squared. So, as you can see, no, that by looking at the given polynomial, you can possibly think that this is not a perfect square trinomial, since the first term is and last term are not perfect square. But then, as you look at each term, you can possibly find the GCF of the given trinomial class. So find the GCF of the given trinomial 3x squared minus 18xy plus 27y squared, and their GCF is 3. So we can factor 3x squared minus 18xy plus 27y squared into 3 times x squared minus 6xy plus 9y raised to 2 or squared. So we will use this one, x squared minus 6xy plus 9y squared, in factoring the perfect square trinomial. So determine whether the first term, that is x squared now, and the last term, 9y squared, is a perfect square. So square root of x squared, that is x times x, we can change that one into our exponential form with the power of 2, that is x raised to 2. While the last term, square root of 9, that is 3, and square root of y squared, that is y. So we have 3y times 3y, so we can change this one into exponential form, 3y raised to 2. That means both of them are perfect square. Determine whether the middle term here is negative 18xy, is twice the product of the square root of the first term, which is the x, and the last term, that is 3y. So we have so we will use negative 6xy. So negative 6xy is equals to negative 2 times x times 3y. So we have negative 2 times x, we have negative 2x times 3y, positive 3y. So we have negative 6xy. Since the condition 1 and 2 are satisfied, then x squared minus 6xy plus 9y squared is a perfect square trinomial. So the factor for 3x squared minus 18xy plus 27y squared, we have 3 times x minus 3y squared, or 3 times xy times 3 times x minus y times x minus y. So let's change this one. So 3. So we have 3 times x minus 3y times x minus 3y. Last example, we have example number 5, factor 75t cubed plus 30t plus 3t. Now, same with example number 4, when you look at the given polynomial, you can say that the first term and the last term is not a perfect square. But then, each term has the same GCF, and that is 3t. So, you will use the steps in how to find the GCMF. You will get 3t there, so that we will now have 3t times 25t squared plus 10t plus 1. So we will use 25t squared plus 10t plus 1 in finding factoring the perfect square trinomial of our given polynomial. So determine the first and last term are perfect square. So we have 25t squared. So the square root of 25t squared, that is 5t. So we can change this one into exponential form. We have 5t raised to 2. And for the last term is 1. So we have 1 raised to 2. Both of them are perfect square. Since step number 3, determine whether the middle term here is 10t now, is twice as the product of the first term, the square root of the first term, and the last term. So we have 10t is equals to 2 times 5t times 1. So 2 times 5t, 10t times 1, 10t. Since the condition are satisfied, condition 1 and 2 are satisfied, that means 25t squared plus 10t plus 1 is a perfect square trinomial. Now, the factored form for this one is 3t times 5t plus 1 squared, or 3t times 5t plus 1 times 5t plus 1. Now, if you are my student, I would like to ask you to answer this one in your notebook. Factor the following completely by writing each of the perfect square trinomial as the perfect square of binomial. Write your answer on your sheet of paper or in your notebook. So, we will check this one tomorrow, and I hope that everyone will get the correct answer. And another one, so I want you to complete the paragraph below by filling the blanks with correct words or figures, which you can choose on the box below. Each word or figure we may use repeatedly. Write your answer on your answer sheet or in your notebook. Okay? Thank you so much for watching. I hope that you learned something about this lesson for today. Please don't forget to like and subscribe and share it with your grade 9 friends. Thank you so much, and God bless everyone. Goodbye.